Hello, everyone. First of all, I'm really sorry I couldn't come and give my talk live in front of you. I was very excited. I packed all my bags, but that something happened that I need to stay here in Netherlands. But that shouldn't stop me from delivering my talk. And I'm really thankful to the organizers that they made it possible for me. And that's why what I'm going to do is present my talk like this. And I hope you still like the content. I'm pretty sure it will be interesting because the things that I want to show is something really interesting, at least for me. But let's start. So what I'm going to talk about is the weather forecasting. So the product that we use in Netherlands, I would like to show what kind of technology that we use, what kind of impact that we make in day-to-day life. I'll also a little bit touch about how weather forecasting works in general, but this talk is mainly about all the technology related thing like Kubernetes, all the stuff that we use. So that will be the part of this discussion. Let's already start. Uh, so as you can see in the photo, I also put the weather forecast live for Bologna. That also means that our product is not in only Netherlands, but in whole world. You can see the weather. Um, how many daily users that use the product? So 15 million was the highest number of unique users that we got in last summer. That's the amount of people who rely on the product. Now I will use Buienradar because that's the name of the weather product that we use. Now you can imagine the word itself is Dutch because Buien in Dutch means rain. So in general, it's a rain radar. So you can see how the rain is progressing. As you can see, the population of Netherlands is 18 million. So of course, we do not expect babies and toddlers to also view the weather. But as you can see in the image, the product is used throughout the world. Of course, our main focus is always Netherlands, but since many people go outside of the Netherlands, they promote it, and this is how they use the product, and this is how it's visible that number of people that use it. Let's talk a little bit about the numbers before we dive into the technology part, because these numbers are also somewhat related to what I want to show. So total page views that we get for Buienradar for website and apps is 5.8 billion per year. Number of unique users, as I already shown you, 15 million per year, or on average, we have 10 million. We have 80 plus radars. In a while, I will show you a little bit about what kind of radars they are. We send millions of alerts every day. What kind of alerts are there? I'll also let you know in some time. So far, our best ever day had page views of 80 million in the span of 12 hours. Availability during the highest load was 100%. And the last but not the least is the number of developers. So we are only 7 of us who takes care about whole of this product, and how, and that's the part I would like to show. And that's the part I'm also very proud of, that with a very small amount of team, we make a large impact. And that's the story I want to tell you. The image that you see that shows the Buienradar or the rain radar is number 1 in online reach in Netherlands. What does it mean? So there is a government website who takes care about all the Dutch website or products that makes the largest reach. And we are number 1 since last June 2024 in terms of reach. What does it mean? Buienradar is the product that reaches most of the people in the Netherlands, somewhere around 42% compared to all other brands. Of course, we do not check YouTube, X, Facebook, because that are not part of a Netherlands brand, but this only shows the brand that are there in the Netherlands. Moving on, as I already showed you, so we are 7 developers. I also wanted to put the image of everyone, but of course, we do not want to show the real images. That's why we put the image that we look like. So now imagine if we have a team of Professor Vin Diesel, the impact that we make. And Annalise and Ricardo couldn't find that lookalike. They think they are unique. So, and we also have one Italian, as you can see, Marco works, and he also was raised near Bologna. So he was also very excited that I'm delivering this talk in Italy. Who am I? So my name is Neel Bhatt. I work as a solution architect for Buienradar. I also work as a chapter lead for RTL News and Entertainment. From this talk, I also become international speaker because this is the first time I'm speaking outside of the Netherlands. But this is what I like to do, speaking about the good part that we do. I'm also a tech blogger in my website, neelbhatt.com. I also like to participate in Stack Overflow, DZone. I'm also a Microsoft community member. So this is what I like to do. And below are some of the companies I work with: MasterCard, Blue, Buienradar, RTL News and Entertainment, S&P Global. So that's me. Now, the agenda, the real part. So what I will going to show, first I will show the product. Of course, I'm not a salesman and this is not a sales speech, so I'm not here to sell this product. The reason to show the product is so that you know what kind of work what we do, and then the later part will become more sense. I will also show how does Buienradar work, like how we make prediction live. So that's something I will show. I will also show the journey towards Kubernetes from where we started, where we are, and also the learning, of course. I will show a little bit about the architecture that we have end-to-end. And last but not least, I will show 7 techniques that help us. Those are mainly the technology or the cloud or the DevOps part. So that's the agenda for my talk. First thing first, the product. So I already mentioned, so as you can see in the image, the rain is moving. So if you put your location on top, it shows when and exactly which time the rain will be. So what we support is nowcast -1 hour. So we show right now what is the situation. That's also in terms of lightning, earthquakes. We show everything that is happening now. We also have forecast. So just after nowcast, we have forecast. So you can see 3 hours, 8 hours, 24 hours, 48 hours in terms of radar, like when and how the rain will be. We also support 5 days forecast, 14 days forecast, as you can see in the image below. We have weather reports multiple times a day, so user can see what kind of weather it will be on the same day. We also have different weather maps where you can see temperature, wind, anything that is related to weather. So our product is rain radar, but it's a weather platform. But there is more. We also support all kind of weather maps, which are, as you can see. So we also have one of the example is terrace radar. So we show when and exactly which day is good to go on terrace and have a beer. We show in the span of 5 days. We also have barbecue when it's a good time to do barbecue. And the good part is we have alerts for each of these maps. So for example, if tomorrow is a good day for going to terrace, you can set an alert. On that day in the morning, you receive a notification that shows, hey, this is a good time to be in terrace. So that's the kind of alerting that we have. That's why I already mentioned we send millions of alerts every day. But alert mainly is used in terms of, sorry, in terms of rain. So whenever, for example, you are out, there is 10 a.m. right now, and if there will be rain that starts at 10:15 a.m. So you receive an alert before a few minutes that, hey, there will be a rain starting from 10:15. So that's why user can change their routine and everything based on the rain that is coming. Apart from that, we also have VScene. It's like a magazine, but for weather, who are very enthusiastic about weather. We have weather photos and videos. people can go there and upload the photos. We also have RTL TV channel. So if you upload a photo and if it is good enough, that it also get broadcasted on television. And we also have live webcams. But there is more. You can go and check Buienradar or reach out to me if you have any questions. Now, how does Buienradar work? So we have 2 real radars in the Netherlands, which are not owned by Buienradar, but which are owned by KNMI, which is a government site. What are there? One is in Den Helder, one in Herwijnen, as you can see in the photo, that covers most of the Netherlands, but not just Netherlands. It also covers majority of Belgium and some part of Germany as well. So what does this radar do? That scans entire sky for every 5 minutes, 24 hours a day, looking for precipitation. These radars were mainly created during war to see what kind of weather are there when they go out in the sea or when they wait for enemy. So just to continue on how this transmits. So what does this radar do? That transmits radio waves which collides with the raindrops and reflect back the radar tower. As you can see, if there is a raindrop in an environment, we send the signal and we get back the signal because it gets reflected. And based on the distance, we decide, okay, this is the place where it's raining based on longitude and latitude. The radar tower receives the signal, again, measures and difference in time and determines the distance, as I already mentioned. The strength of the reflected signal is also used to determine intensity. So if the rain is very hard, then we also determine based on the intensity or the reflection that we get. So this is how at least the nowcast work. This is not for the forecast, because for forecast we use modeling, intelligent computers that predicts based on the situation for each and every location. And we don't just use this radar, we also have data from UK, Germany, Belgium. We are also integrating with France. So we combine most of the data, we put it in our radars, and this is how accurate the weather is. But I will be very honest with you, the weather is perfect for Belgium and Netherlands at this moment. So if you watch it in Italy, it might not be as perfect as you can see in Netherlands. But that's also our focus, that we want to be very much predictive in Netherlands and Belgium right now. Now, turning towards Kubernetes. So as you can see, the left side, we had monolith that started from 2008 until 2019, and it ended in 2019. What does it mean? So as you can see, this is the front image of our app. We only had 3 of the APIs: data API, image API, and subscription API. That's it. So everything that you have in the app, all the data comes from data API, all the images comes from image API, and we also have subscription, which I didn't mention, but people can subscribe with some €4, and you can get no ads and everything for 1 year. But this is how our code looked like. So we had just one monolith where everything was there. If something breaks for this part, or if this whole package is not working, then the user see it, of course, because everything stops. And it's also not very good manageable in terms of code, because if imagine 3 or 4 developers working on it in the same repo, that was not an accurate part. But it was working back then, and it was working fine. But when I think now, I feel like, okay, that was a pain. So what we started doing from monolith, we started converting to microservices. So for each and every domain or the different responsibility, we started picking up, and this is how we started dividing. So what we started doing is microservices on Azure App Services that started in 2019 and ended in 2022. What does it mean? So as you can see, now things are changing. Location bar is going and checking location API, image API, still image API. The graph that you see checks from graph data API, but there's more. We have traffic related information as well. You can see on which highway there is like a very big traffic. We also have integration with public transport, so you can see which of the train is getting delayed. And for that, we use traffic API. We have observation API, which shows what is the observation of weather right now. We have forecast, as I already mentioned. We have VScene, we have photo video, we have user alert API, and we have subscription API. On an average, we have somewhere around 14 to 15 API that takes care about all different part of the app. And that also makes it easier for us to deploy and of course, manage, because now each and all API is with a hexagonal architecture. So we can manage that in the code as well to separate out different layers. And it's also possible that multiple developers can work on it. But that was not enough, of course. We want to go forward. What does it mean? So after microservice, we started implementing Docker. And that started in 2022. That's also the time when I joined the company. So this is very special, of course, because this is something I also wanted to do. What does it mean in terms of, but let's go to the basic. What is Dockerization? So containerizing microservices, because all the microservices that you saw was on Azure Web Services. We wanted to containerize them, ensuring consistent environments, faster and isolated deployment, so that we do not rely on each of these microservices. They are independent. It's also possible that your local development makes it better because of you can deploy anytime. The best part I like about Docker is you cannot have the argument of, hey, it works on my machine, because Docker is literally putting your machine and deploy that. What are the benefits of Docker? So as I already mentioned, works on any system. So you can put your code and as a container, and that just works. It's lightweight compared to virtual machines, because virtual machines are very heavy in terms of the load, and enables CI/CD automation that I will also touch in some time. The Docker journey, what we did, initial adoption was packaging apps as containers. So that's something what we started doing. Our initial microservices were in Windows, but we started that converting into Linux machines, standardized container images, managing container life cycles, orchestration of challenging rises, of course. But this was, to be honest, only the middle part. This was not the end, because the end journey was Kubernetes, and Docker was part that we wanted to do, because to have containerization is very much important when we want to go towards Kubernetes. Now, so that's the part we started. So after Dockerizing all of our microservices, now our time was to go to Kubernetes. What does it mean? From 2023, we started moving all of our APIs or all of our infrastructure to Kubernetes. What is Kubernetes in a nutshell? So from, as you can see in the control panel, you can control all the worker nodes. That is nothing but the applications that are deployed. That makes it easier for rolling back, for auto scaling, and all these things that I will show in a bit. But before that, what was the limitation? Like why we wanted to go to Kubernetes? With Docker, managing multiple container was a complex. Scaling and networking, this is the biggest one, scaling and networking issues, because for Buienradar, the traffic goes up suddenly, and that goes in millions. Imagine a day with sudden rain. There are like millions of users come suddenly on the platform, and we have the peak of users. That's why we really need very aggressive scaling, which was not possible with Docker. What we were doing before, like we were setting up, hey, tomorrow will be bad weather, so we go to Azure. We have like a way to upscale, but what does it mean? We upscale in the morning until the night. So it means we also were spending more money than was needed. Last part is about load balancing and resilience concerns were also not that much good in Docker in terms of, again, when there was a traffic. Kubernetes to the rescue. So why we wanted to go to Kubernetes is, of course, one of the things is automated deployments, rollbacks, and scaling. As you can see, we are only 7 developers. If we make one mistake, it is visible by millions of users immediately. So we also do not want to put something that breaks. So that's why with Kubernetes, we implemented automatic rollouts, rollbacks if something goes wrong. Scaling, I already mentioned, we have lots of users suddenly. So this with scaling, it really helps. Self-healing. So if you have pods that's not working, it just kills the pod, creates a new one. And this is how Kubernetes helps us to always be available, because that was one of our goals, that we always want to be available for people to see the weather. Service discovery and networking, configuration management, load balancing. I will not go too much into detail because we don't have too much time, but these are mainly the reason. Now, how does Kubernetes work in our company? So we have Azure pipelines. Let's say you make a change, you create a PR, it goes to Azure pipeline, it builds. As you can see, it creates a in my report, it creates the registry. We push this image to Azure Container Registry, and we use GitOps. I will mention a little bit because there are two new words now, GitOps and Argo CD. I will a little bit explain about this too as well in a moment. But what does it mean? So we, on the basis of the registry, we also update GitOps repository. It's nothing but kind of managing your infrastructure, but from your code. Argo CD is something that pulls from that infrastructure as a code and determines what and how to build and deploy. And then we have different environments. As you can see, we have test, we have acceptance, we have production and production. So we have for production two, one is in west and one is in north to make proper load balancing. But we always make sure that we test everything before we go. That's very obvious to mention, but still. What is GitOps? GitOps in a nutshell, it's infrastructure as code. All of our your condition that you want to put, let's say, how many maximum number of ports you want in Kubernetes, like how many anything that is related to deployment is part of Git. That's why it's at GitOps, because all of your rules are saved in your repository. Config management, application code. So that's like a source of truth of everything that you want to be part of your deployments. Whenever you change something, it gets updated, and CI/CD runs based on the rules that you created, and pipeline runs a series of tasks resulting in the update on the runtime environment to match the source. So that's in a nutshell. Of course, you can go and check more about GitOps, but we use it and it works very well for us. And then what is Argo CD? So Argo CD is implemented as a Kubernetes controller. So in a nutshell, it is a controller which continuously monitors running application and compares the current live state against this desired state of target state. So as you can see in the image, when a PR is merged, it goes to Git, and then all the changes is controlled by Argo CD. So Argo CD has its own UI. From there, you can see all the application that is being deployed. You can see different ports are getting created. From there, you can also sync if the sync is failing. From there, you can also see some of the logs like, hey, why my application is not running. In a nutshell, it is more like the controller as we saw in initial image about the Kubernetes part. And there are different hooks as well, as you can see with Slack. So if you deploy something, you can also automatically go back and mention that in Slack that, hey, this happened. And then it also deploys in different environments. So how we use in our Buienradar, as you can see, this is the UI of Argo CD. These are all the APIs and all the infrastructure that we manage. And as you can see, it is tightly visible with each of them. If you click one of these, it shows how ports and nodes are created for each individual of those apps. Now, going back to the architecture. So we have two main parts of architecture. We have a bunch of APIs, as I already mentioned, and then we have data processing. So data processing works continuously I will show in a bit sometime, and APIs gets the data from database. But before moving to that, these are all the tech stack that we use. We use Docker, already mentioned. We use .NET, we use C#, we have React in front end, we use Grafana, Prometheus, Argo CD, MongoDB, Kubernetes, everything. So API architecture, we want to keep our API as simple as possible. That's why the simple architecture, as you can see, user asks for something, it first goes to API gateway where it takes care all about caching, security and everything. And then it goes to individually each of this API that you can see. What this API does, it goes to check in the cache because, as I mentioned, we want to be available most of the time. So that's why we first check in the cache. If there is no data in cache, or if the data in cache is old, then we go to storage and get the data and update the cache as well. So most of the time we get the data in cache. But this one is more interesting. So how we combine API and data processing. As you can see on top, we get the data from different sources like satellite, radars, intelligent computer models. We get data from government as well. For example, if a child goes missing, we also show it on our website that we call it Amber Alert. So what does it do? Like we get all the source. We have like data processing microservices. Some of them runs every minute, some of them runs every 5 minutes, some of them runs every hour. It continuously runs. It gets the data from all of the source, parses, puts in the queue, and then we have different cron jobs, which we are moving most of our Windows services to cron job in Kubernetes. What does it do? It runs very intelligent algorithms, put some data, for example, as I mentioned, when it's a good time to go and do barbecue. So all kind of that logic, we want to keep it in the data processing, and we want to make API as light as possible so that the logic or the important discussion logic is not done when a user asks, but this happens when we create the data. So out of this, it creates different images, weather maps and data. What it goes directly to the storage. As you can see, we have circuit breakers, retry, and everything in between when a user asks from the API side, because API just calls and gets the data from storage. We also have a management console from where we can manipulate different images based on a lightning, for example. Suddenly, we call it popcorn cloud. You cannot always forecast lightning, but based on that, we can. The meteorologist specially goes there and changes some of the images to be visible. Now, I want to show 7 techniques that help us, mainly in terms of DevOps part. Of course, this help us. It does not mean that these are perfect, but I still want to show you. First thing first, strategic deployment. So what we do is we use canary release. If you don't know, canary is a bird, and in somewhere in 1800, when people go to mines, they use this canary bird because canary bird is very much like it can detect carbon monoxide, for example, and when it detects carbon monoxide, it feels and it's visible that the bird is not comfortable. So that's why people used to use this in caves when they go there for mining. If they see canary is not feeling well, they can immediately say, hey, this is not a good place, let's go back. Canary release is somewhat similar. So canary deployments are in rollout. So we, as you can see in the right side, this is the code. We first put live for 5%, then 20% for 15%. So we want to see if our changes first is good for small amount, and then we roll out to more and more people. And if something goes wrong, we immediately roll back so that the user do not see faulty or something breaking. Apart from canary release, we also use SLO alerts. So I will mention a little bit in other topic as well. So we have different SLOs. Whenever something is burning, for example, there are like lots of errors suddenly happening, 500 errors, then we have a way that we get alerted as soon as possible, and then we can work on it so that user do not see it. We use a feature flag. So going live is mostly or most of the time just enabling feature flag, and we want to continuously put our changes in production. We can deploy anytime. Most of the time of the day, we have not we do not have one big release. And last but not least, the power for observability, which I have as a separate topic. We put lots of efforts in observability. So we want to maximize observability. We use OpenTelemetry for that. What does it mean? It's an open source observability framework. It's like a framework. You can plug your code, as you can see here, with the OpenTelemetry collector, and then you can use any of the UI. You can use Splunk, you can use Honeycomb, you can use anything that you want, a Grafana, but the framework is similar. That's why it is very beautiful. If you're not using it, I will highly recommend it to use this. And now how our observability looks like, as you can see on top, we have different ports. From Argo CD, you can release, as I already mentioned. From this port, it goes OpenTelemetry collector, and from OpenTelemetry collector, it goes to different things that we use in Grafana. It goes to Tempo. If you want to show them different metrics, it goes to Mimir. If you want to see different logs, it goes to Loki. These are all the naming that Grafana uses. And I will show you a little bit on how it looks like. So this is the dashboard that we have for all of our APIs in Grafana. You can see we can monitor how many ports are visible, how much CPU usage is there, how many number of errors are there, what is the latency, how many requests are there. You can see the different patterns throughout the day. People use Buienradar, and that's how we also do scale out and scaling accordingly. But we want to have something visible, and this is one of the things that we can keep an eye on. But that's not it. We have different app metrics. What does it mean? If you can go to location API, for example, you can see everything for that. You can see response time, you can see .NET container, port count, usage per node, logs, HTTP rate, OpenTelemetry, anything. And this is very important for us because we want to have maximum observability. And if we notice something, we can immediately work on it because it puts all of your logs. You can see, okay, this is the error that's coming 2 months. So then we can go and fix that. But this is not it. We also use it for missing locations. As you can see, we had a situation where we were getting lots of missing locations. We put it on Grafana, and these are the locations which we do not support, but it was possible for us to visualize them. Next is designed to handle failures. Failures are something we cannot predict, but what we do, we use circuit breakers. What does it mean? So if you see that your service is getting 500 errors, we do not want to bombard the service. At one point, we open. So what does it mean? So we open the circuit breaker. We do not allow anything from service. And that also helps service to recover, because if you bombard too much, if the service is already failing, it's also not good for the recovery. So that's why we just open the circuit and we let the service to recover. How does it look like? Again, in Grafana, as you can see, we have most of the time circuit closed, but if something opens, circuit breakers is for all different ports. It turns red. It says open, and then it's just so small amount of time. But from here, we can also see when and how the circuit breaker was open. So we can also plug our alerts based on that. Second thing is retry. As it shows, we retry 3 times if service is not responding. And after one threshold, we stop. We have exponential retry. Again, Grafana, you can see it retry 1 time, 2 times, 3 times, and then it stops. We do not, and the timeout and circuit breakers are related with each other. And this is how we stop at one point. Third point is timeout. Again, related at one point, if retry doesn't work, we time out after a number of retries. As you can see in this image, in Forecast API, at one point, we have different timeouts. We see it, and then we saw, okay, something is not going wrong. But we have different, if you have observed, we have different way to show timeouts, circuit breakers, everything with Grafana. So it's not just theoretical, but it's also something we can see that, hey, this is working how we want. And last but not least is self-healing Kubernetes pods. I already mentioned Kubernetes also takes care about healing. So something goes wrong, it heals itself. And as you can see here, at one point, it automatically shuts down the application and restart, because most of the time, if product owner asks us, hey, something is not working, first thing that we do is go and restart. And now we don't need to do that because Kubernetes takes care of that. And the configuration that we have set. Prepare for failure. So Buienradar is very famous, as I already mentioned. If we make a mistake, we go viral. So that's why what you can see at one point somewhere in 2022, we were suddenly showing 35° in a month of October, which is not usual. So that was the part we went very much viral. As you can see, right side is all the media, big media industry that were showing, hey, Buienradar is messing up. So that's why we want to prepare for failures, because otherwise we go viral. What do we do? This is the right side that shows the whole integration that we have. So we have a PagerDuty integration. We have automatic alerts, SLO alerts, I already mentioned, trigger alerts manually. So if something goes wrong, tightly coupled with Grafana, we raise an alert. What does it do? It acknowledge, like it just literally calls you. We put some time so that we do not get call after 10 p.m. until 7 a.m. But it's an automatic call. You call if you cannot call, because we have rotation of the people. If somebody is not available, it calls somebody else. So there is like a rotation of calling. What we do most of the time, we acknowledge, we act on it, we mitigate, and then we do the postmortem. This is one of the example of SLO alerts. So as you can see, our target is most of the time 100%. But if it doesn't go, let's say we have target of 95%. If the number of errors goes below that, then we raise an alert, and this is how we can manage most of our APIs. This is one dashboard of showing API alerts to show that we have number of incidents last year. This shows the amount of time we took, and this which is amount of time of acknowledgement, which was 9 minutes, and amount of time we use for resolution. But I will show P1 because that's the highest one. We only had one P1 incident last year. The acknowledgement, as you can see, was in 1 minute and 46 seconds, and we resolved it in 30 minutes. So this is possible because of all the process that we use. And then last but not least, we use the postmortems. As you can see, this is the template that we use. We have summary, impact, timeline, root cause, what went well, what didn't go well. We do postmortem most of the time if it is P1 or P2. For P3, we create a task in our backlog, but this is very important for us because we want to learn from what went wrong. Failing is fine, but learning is very important. Fifth point is auto scaling. As I already mentioned, traffic goes rapidly. As you can see, somewhere in the 6 a.m. and until 6 p.m., the traffic goes like this because this was one of the rainy day. So that's why we have like a very aggressive auto scaling. This shows the auto scaling of Grafana, Graph Data API. As you can see, somewhere around 9 p.m., we saw a very big traffic, and that's also visible in the image below. The number of ports like suddenly increased from 10 to 50 in matter of seconds. So this is how much aggressive scaling we use. And then as you can see, once the traffic was down, also it's very much related to the image above. When the traffic was going down, it was also downscaling because we also do not want to burn too much money. So that's why that shows all the auto scaling based on timestamp. Sixth point, that technique that helps us, we want to keep the latency low. We use caching, a lot of caching. We use CDN, so all of our images and static things are stored in CDN. We use cache store with proper TTL. As you can see, this is the time that at one point TTL or caching expires and it fills again and it expires again. So this is how we make sure that the data is always latest. Response cache to avoid calling API frequently. We use lots of response caching in API so that we do not call API too much. Apart from caching, we also use load balancing. As I already mentioned, we have PRTW, we have PRTN, so west and north. We follow DDD, proper domain-driven development. How does it help? Is like we have proper segregation of responsibility. If we have forecast API, it only takes care about forecast API so that it does not do anything for location API, for example. With this, you can keep latency low because that's only one thing that is done by this particular API. And this is what we believe, that we do not want our APIs to do multiple things. And last but not least, we observe and monitor. The thing that I already showed, we keep an eye very frequently. It does not mean that we go and check that every day in our office, the dashboard is there. It's also visible, something turns red, or we have proper alerting. So we get alerted first before a user notices that. This is one image that shows one example that every morning or somewhere around 4 a.m. we had high latency. From this image, we realized, okay, why this is happening. This was happening because of Elastic. At one point, we were calling it too much because the cache was expiring exactly on that time. So like this, we keep an eye whenever there is a high latency, and we can also fix that. Last point is use spot instance. If you don't know, Azure or Microsoft has discounted rates due to utilizing of Azure surplus capacity. So at one point there are discounted rates of pods or virtual machine in one way are available suddenly for us. What does we do? We optimize infrastructure costs for using those spot instance. So for example, in our test or acceptance, if we reserve, let's say 30 ports or something, it's very costly. But if we reserve only 5 of them and then we rely on spot instance, so whenever the Azure has like availability, it immediately getting used by our test or acceptance. The downside is there is a eviction risk. So if Microsoft or Azure wants those virtual machine back, that only gives us 30 seconds of notice. What does it mean? Our ports and everything should be very much configured that if something suddenly goes, we can put other ports suddenly. So that's why spot instance is unsuitable for all workloads, because that's why we do not use it for production, for example. But just by using for test and acceptance, it is like a very much cost savings, and it helps us to reduce hundreds of euros, of course. The risk includes service interruption, as I already mentioned, job failure if we have 30 seconds notice and if we cannot do that. But hey, if it is test and acceptance and only for some of the part that are not highly or critical, then it's fine. So I would really recommend to check spot instance if you are not using it. It really good for your FinOps. It gives you less amount of money to, but only use it for test and acceptance first, see how it works, and then go for something else. Last but not the least, bonus point, always innovate. You use Shark Tank, we call it. So we pitch different ideas. Learning is really important. We allow innovation. We allow idea sharing. We want our product to continuously develop and do something. We are doing different things. For example, we want rain to be planted on 3D. We can use machine learning for that. We are using AI translation for weather reports. We are using written forecast for different cities. For example, if you go to Bologna from Buienradar, you can see like a very small but efficient weather report that is all generated by AI. We are going to work on AI a lot this year because that's also the focus of our company. So if I am going to deliver a talk, let's say in 1 year, things will be totally different because the amount of work that we are putting in AI and how it can be used with weather is tremendous. And at one point, I will also show it on a later stage, like what kind of impact that we made. So this is to summarize 7 techniques: strategic deployments, maximize your observability, designed to handle failures, because failures are not these are inevitable, but you should have your design that can handle them. But again, you cannot always have handle all the failures. So if something goes wrong, that's like prepare for failures. You should be using PagerDuty and all kind of SLRs for that. Auto scaling is very important if you have a website that have hundreds or millions of users. So that's how we use. I already showed you. Keep the latency low, because if your latency is low, your health of the code base is already very well. And last but not least, for use spot instance to reduce your cost for Kubernetes and everything, and always innovate. So that was my talk. Thank you so much for visiting and being here to watch my talk. This is the QR code. I'm not there, so I cannot see everything, but this is the QR code. If you are interested, please rate. If you have any feedback for me, this will help me to improve. And thank you so much for joining. Bye-bye.